In this relatively longer lesson, what I'm going to try to do is introduce you to all the concepts that we're going to see in this classes, methods, and object section. And the reason why I'm doing this, rather than doing this sort of at the end of the section, is to actually introduce you to all the concepts, because all the concepts are intertwined together. And I feel like learning them all together, showing them how they all connect together to form a class, to form an object, will be very powerful in terms of your learning capabilities. You could truly see the power of making objects in Java when you do it all together. And although I am going to go in depth into different concepts regarding making objects in later videos, I feel like having one video that combines all the concepts, that way you can pause the video, try it out yourself to make the objects yourself, or make different variations of the objects yourself, will help you grasp the concept of object-oriented programming in the Java programming language. So let me first make a sort of demo class. And this is what we've been mainly doing. It has a main method, so that means that we can execute it. Alrighty, so we are going to declare our class, public class demo. Let me put demo class there. And then we're going to have our open curly brackets and then close curly brackets. Then I'm going to declare the main method. And the main method is basically a function of a class that executes first. So the compiler is going to look at the main method and it's going to say, hey, I'm going to execute this. But this is only going to be the case when you have a program that runs an application. So when you're running an application, you're going to need a main method so that you can execute the program. But if you're creating an object, then the object doesn't need a main method because the main method is going to use the object. You'll see in a second. So public static void main string art. Then we have an open curly bracket and then a close curly bracket. So one example of an object I've been using all the time is actually the scanner object. So how do you declare a scanner object? Well, you say, well, first you got to import it. So we're like, all right, import java.util.scanner. And this imports the scanner class of our Java package. Or if we want to just import all the classes, what we could do is simply replace scanner with asterisk, and then it just imports everything rather than just importing scanner. And then to access the scanner, or rather declare a scanner object or create or instantiate a scanner object, we declare a scanner that we want a scanner. So the computer is going to allocate some form of memory so that the scanner can be stored there. And then we simply name our scanner. So I'm going to name it Fozon Scanner. And that will be equal to, with our assignment operator, a new scanner, and then system.in. So what we're doing here is that we're declaring that we want a scanner, we name the scanner, and then we actually create the scanner with this. The new emphasizes that we want to create a new scanner. So how do we access the scanner? Or, well, we've already created the scanner, but now how do we use the scanner? Well, we've already been using that in our previous videos, but just to touch on again, let's say if I want an integer, what I'll do is I'm going to name an integer, a, and then set it equal to whatever my scanner's name is. So I'm accessing the object, I'm accessing the scanner object by its identifier or by its name, because that's what we named our scanner. And then we access a method of the scanner class that lets us get an integer. So the way we do that is nextInt. NextInt is a method within the scanner class that says, hey, we need to get an integer from the user. So there's code within the nextInt class of the scanner class that allows us to get an integer user input from the user. So then when we print out, it will print out what our user input is. Let's first save it. And I have to remove the extra S because we need to make sure that our identifier is correctly named. So when we're accessing our identifier, it has to be 100% correct, 100% the same. Alrighty, so it's going to tell us to enter. I mean, I didn't put the print statement to tell us to enter an integer, but you get the gist. If I enter an integer, it's going to print out the integer that I inputted because that's what I put in my program. So now what I'm going to do in this video is I'm going to create my own class. I'm going to create my own blueprint. Class is simply just a blueprint for a program. It's the blueprint of an object, and it's going to consist of variables. It's going to consist of methods that allow you to use it in a main method. So you know how we have a scanner object? Well, the scanner object is simply just a class, another class. It doesn't have the main method. The scanner class does not have a main method, but you import that into the program. And once you import it, you can create a scanner within our program and then use it to your advantage. So in this program, in this new class I'm going to make an employee class. But before I make an employee class, I want you to think about what truly makes an object. Like, when you look at an object, what characteristics are there? Like, if you look at maybe a student has a name, so that's a string. They can have a grade level, an integer. They have a GPA, a double. They also have a class rank, an integer. If you look at like maybe a business, they have a business name, they have some sort of revenue, they have some sort of profit, they have some sort of expenses, and they have a number of employees. And this is what makes an object. An object is that's what makes an object. Its characteristics make an object. So what we're going to do in Java is we're going to create an object from a class, and we're going to have its own characteristics, but we also have methods. We also have functions within it that allow us to change the characteristics. So let's say if I have a student and then that student is now changing grades. Well, we can change the grade by accessing a method, by accessing a function within that class that changes the method. Alrighty, so what I'm going to do, or what you should be doing, is I want you to create a new Java file. Alright? Now this is where we're going to store our framework. So there's no main method because we're going to use this class in the main method, in another main method, in a different class, because that's where we're going to create the object. That's when the object comes to life, you could say. But here we're creating, or rather frameworking the object. We're providing the blueprint of the object. So to have the blueprint of an object, we have to first declare a class. So I want to declare public class. And public class simply says, hey, I want you to create an object. I want you to create a class, and it's available to be accessible. So public simply says, just like, if you go outside public, it's accessible. So other classes can access it and utilize it. So public class, and we're doing an employee. So we're going to provide the framework, or we're going to provide the characteristics of an employee. So we're going to name our class employee. Then we have our open curly brackets and then our close curly brackets. Now, how do you get characteristics into a class? How do you get the characteristics? Well, you could simply name them through instance variables. Instance variables are basically the variables within the class that characterize or provide the characteristics for the class that we're dealing with. So an employee, what type of characteristics are we going to have? Well, we're going to have an employee name. He's going to have some sort of employee ID. And if he's on a wage, then we're going to probably have a double wage. And when I mean double, I mean a decimal double. Whether or not they're active in the company they're working with. And that's what I'm going to do for now for this video, because I don't want to go too many instance variables at once. But you get the gist. These are different characteristics of an employee. So let's write them down. So we're going to have a private value. Now, you don't want your characteristics to be accessed by anyone, right? So if you don't want them to be accessed by anyone, then you have a private instance variable. So let me emphasize it. Instance variables, and they are usually private. So you're like, all right, private, and then let's say if we want a name. So what type of value is a name? It's a string because it's filled with characters. So we're like private string, and then we have an identifier for it, which is name. Alrighty, so now we've declared one characteristic. So now I want you to do the same thing with the ID, the wage, whether or not they're active in the company, and we'll do that for now. Alrighty, so pause the video and try to do the rest of those characteristics. Alrighty, so I hope you managed that. Let's try doing ID, wage, and whether or not they're active. So an ID is most likely going to be some long integer. So we're going to have private int ID. Then for wage, it's going to most likely be a double. So we're going to have private double wage. Alrighty. And then for whether or not they're active in the company, I'm going to have a Boolean value. So true or false, because they could be working in the company or they could not be working in the company. We're not dealing with part-time, full-time, or no time at all right now. We're just keeping things simple. So private Boolean active. Alrighty. So let me save this. Let me make sure when you're saving it, save it in the same program that you're with another class that has a main method that you're going to utilize. So as you can see, that I'm using the demo class for my demonstration purposes. So when we're going to utilize the main method, make sure that your object that you're going to use is in the same folder as the main method. Alrighty. So now we saved it. Let's make sure that there's nothing wrong with our program. All right, it's good. So now you're probably wondering, why did I end with a semicolon? So why didn't I assign a value? Why didn't I just put like some name? Why didn't I put some ID? Why didn't I put some wage? Why didn't I put a true or false for the active right from the get-go? Well, the reason why is because think about it. Right? You don't have just one employee in a company. You have multiple employees in a company, and you can't just encompass that with one name, with one ID, with one wage, or whether or not they're whether or not they're active in the company or not. So you're gonna have multiple employees. So what you're gonna do is you're gonna create multiple employees, and we do that through a constructor. So if you remember from our scanner class, this is actually accessing a constructor. A constructor is a special type of method because it doesn't follow like the main method sort of declaration, nor does it follow the other methods we're going to look at later in the video. So it's really its own special method. But what it's really trying to do is that it's accessing a constructor called scanner. It's accessing a method called scanner. And then the scanner here says, hey, we're going to create the object. So new scanner, and then it creates the object and then stores it within scanner. So how do we do that in a Java program? Alrighty, so as I said before, it's a weird type of method. It doesn't have like static, void, main string args. It doesn't have that. It's basically just public because you want to access it, because when you want to create the object, you want to access it. So public, and then it's just simply the name of the class. So you have public class employee. Well, that's the name of our constructor. But just like a method, it allows for arguments. So as you can see here with the scanner, it allows a system.in argument. Now, I'm not going to go into what a system.in argument is. I don't think you need to know that. But just so you know, constructors take arguments just like a regular method. I mean, it is a method, but just like a regular method, you could say if you want to create the object, you can send variables out to the employee class. So we can do this actually two ways. So we want to fill up four different characteristics, or four different variables, four different instant variables. So we can do this two different ways. I'm going to show you the easiest way, and then I'm going to show you a slightly more advanced, nice way. So let's say we have an String n, that's going to be the name. Integer n, integer I, which is going to be our ID. We're going to have a double W. That's going to be our wage. And then we're going to have a Boolean A, which is going to be our whether or not the company is active. So when we're creating the object, then what it's going to do is it's going to access this employee class, or sorry, employee method, employee constructor. And the reason why we call it a constructor is because it constructs the class. And then when it sends the values, it's like, alrighty, name is going to be equal to n, ID is equal to I did not write I, W, no, sorry, not W, wage is equal to W, and active is equal to A. So let me finally actually create the object. So, just like a scanner, you're going to be like, well, let me first save this. Build, file, save. And let me make sure there's no errors here. Alrighty, good. So just like a scanner, we're going to call it by the name of the class. So what is the name of the class? The name of the class is employee. Alrighty, we got employee. Alright, make sure that it's spelled correctly, E-M-P-L-O-Y-E-E. Hopefully that is the correct spelling of an employee. And then we can name our first employee. So not necessarily like name, I mean like just an identifier for the employee object. So let me put maybe employee 1. And then we're going to set that equal to new employee. And now what it's actually doing is that it declares that it wants to make an employee object. So the computer is going to allocate some sort of memory or some memory so that a employee object can be fit into it. And then this actually creates the new employee. So what this new employee does is that it emphasizes that we're creating a new object, and then employee is actually accessing the employee constructor over here. So the employee constructor says, hey, I need a string n, I need an integer I need a double wage, and I need a Boolean A. So let's say the first thing is string n, and string n is our name. So our name is going to be, let's say Fozon, keep it simple. Integer I is our ID, so I'm going to keep it simple again, 1, 2, 3. Double W, that's our wage, so let's be like $30 an hour. Actually, let's put 30.1 just to make sure it's a double. I mean, it is a double with a decimal, but you know, 30.1. And then active, we're going to put true. Alrighty, so we've basically declared an employee that we want an employee, then we actually create the employee through a constructor. So it takes in these arguments and then it creates the object. So we can compile, and let me do this. Alright, compile, and we run. And it does nothing. And the reason why is because we haven't inputted any functions. But what is happening actually in the background is that we're like, all right, we've created some sort of employee. And that employee has a name of Fozon. It has an ID of 123, has a wage of 30.1, and is active within the company. And it just simply accesses this method of the employee class. Now let's say that the person does not want to put anything between the parentheses. It just simply wants to create an employee object. Well, what we can do is we can make a default constructor. And what it does is that it's simply, sorry, not public class, public employee. And what it does is that it pretty much automatically makes name equal to null. Basically, there's nothing stored there. ID is equal to 0, wage is equal to 0.0, and Boolean active is equal to false. It automatically does this because, well, we didn't really, because that's what happens when you access variables without assigning a value to them. So we can make a scenario where we can access it without putting any arguments into our method, into our constructor. So let me first save that just to be sure. And compile so that there's no error. Alrighty, good. So we can make an object like this and without any arguments. But if we want to make it with, we can make actually multiple employees, and we can utilize it both ways. So employee, let me make sure that identifier is correct, and then we have a new employee with his name Fozon 123 30.1 trill. This both ways will work because we have two constructors that allow. We have a constructor that has arguments, and we also have a constructor that doesn't have arguments and it doesn't put anything, or rather doesn't use that much space within the instance variables. So you're probably thinking, like, why is this so dull? Like, we just created a bunch of objects, but we're not really doing anything with them. Well, this is where methods come. We've already established that the constructor is a weird type of method because it's simply just public and then the name of the class. But now we're going to do methods that you're probably comfortable with from the introduction to methods video. So so there are two types of methods that I'm going to cover in this video. One is called a accessor method. So let's say if I want to access a value, if I want to access, because if I try to access any of these names or an ID or a wage or some, or the Boolean value for active, I can't do that because these are all private values, and we would want private values to be our private instance variables to be private. But we can access those private instance variables through a method, and the method should be public. Now, something that you're probably not aware of is that you do not use void in this case. And the reason why we don't use void is because we want to give back the user something. Void is what we have in this location actually is a return type. And there's different types of return types. We have an integer return type, we have a string return type, we have a double, we have a Boolean return type. You know, all our primitive types, or rather just any type of variable in general, you can actually return it. But if we do not want to return it, that's when we use void. But we are returning a value to the user. We want to return the value or these values to the user. And we do that through an individual class for each of the values themselves. So I'm doing a little messy scrolling here. All right. So we do that through, what do we want to return? So for my first method, I want to return the name. And our name is a string. So our return type is going to be a string. Do not put void because we are returning something. When we do not return something, we are going to have a void. So, but we are returning something. So public string. Also, do not put static. I'm going to also cover what static actually means a little bit later in the video. So make sure not to put static. Unlike the main method where we put static and void, we're not going to put it here for this accessor method because we're accessing a value. So public string, so we're returning a string. And what do we want to name the method? Well, I want to name the method getName so that when someone accesses it, we are going to we're going to get the name. And it doesn't take any arguments because it's simply just executing a function. So we're not giving it a value, we're just getting a value from it. Have an open curly bracket and then a closed curly bracket. Alrighty. And then something that you haven't come across is actually called a return statement. So when we have a return value here, basically anything that's not void, you need to have a return statement. Without the return statement, the Java is going to be like, hold up, we don't have a return statement. I don't know what to, I know what type of thing I need to return, but I don't have the thing that I'm returning. So we need to have a return statement. And lo and behold, the return statement is simply just return. But what are we returning? Well, we can return it two different ways. There's the two-line method, and then there's the plain and simple method. So what you could do is be like, alrighty, string name. Alrighty, so let me put string a is equal to name. What it's going to do is that it's going to create a string. It's going to access the name from the instance over here. It's going to access the name here, and then it's going to store it into a, and then you can return it like that. Or you could just skip that step entirely, and what you could do is just return name. And then what that does is that it sends out to the program when you're accessing it, it sends out to the main method when you're accessing it, the name of the employee. So let's see how this actually works. Alrighty, so let me first save it, and I'm pretty sure it compiles correctly, so we should be chilling there. Let me also make sure that we have our labels, Accessor Methods. Alrighty, so we're back into our demo class. Alrighty, so just to recap, we are declaring our employee, and then we create the employee, and then we send these arguments out to the constructor. And then what the constructor does is that it takes in the values, string n, integer I, double w, boolean a, and then sets it into our instance variable. So we access the instance variables. Name is equal to n, ID is equal to I, wage is equal to w, active is equal to a. And then these values actually make up the class. It's the characteristics of the class, the variables of the class. But now we want to access it. So how do we access it? Well, just like how we did scanner, whatever the name, scanner, and then we do new scanner system dot in. Well, and then we do like integer a is equal to, then we access the name of the scanner, and then we access the name of the method that we want. So we want an integer, so we're like next int, and then we do parentheses and then close. So what it's actually doing is that it creates a scanner object, and then it's like, all right, name, because that's the name of the class or the name of the object that we created, and then it accesses this method of this object to allow us to get user input. So the same logic applies here. We can have employee 2, because that's what I named it. I should have kept it employee 1, but we're gonna try employee 2. Then we're like, alrighty, dot, and then how do we get name? So we get name. So that's the name of our method, so that's how we're gonna access it. Get name. And whenever we're accessing a method, we're always gonna have parentheses. If we have no arguments, then we simply put nothing in the parentheses. But if we do have arguments like our constructor, then we gotta make sure that our arguments are there and the correct arguments. So we have 4 arguments for our constructor. We have to make sure that there are 4 arguments for our constructor. Alrighty. So what it's doing is that it creates a employee object. That's the name. So whenever we're accessing the employee object, it gets the name. Whenever it has the identifier. So whenever we access it through this name. And then it has these values, and then these become the characteristics of the class. It becomes the instance variables. So we have our name, we have our ID, we have our wage, and we have our whether or not we're active in the company. Then we access our employee object through its name or its identifier, and then to get the name, we access the get name method, and this is going to return the name. So compile, everything runs, and then we run it, and nothing happens. Why do you think that is? Well, we're not actually telling the compiler to print anything out. We're simply just saying return the value out to the user. So we can go about this two different ways. So just like how I had integer a is equal to phosons scanner dot next int, we could do the same thing with employee to get name. We could be like, alrighty, string name is equal to employee to dot get name. And the reason why I can use name is because name here is a private instance variable and it's using a different class, so it's only going to work in that class. And we have a name here, which is in a completely different method or different class, so that's why I can use name. Right? So it's like, alright, I'm going to return a name, and then the name gets stored into name, the name value here, and then we can print out the name. And then we run it, we actually get phoson. Even though it's not specified in our class, we're actually creating an employee object that has the name phoson, that has an ID of 123, that has a wage of 30.1, and his active within the company is true. And then when we're accessing that name, when we're accessing that name, we use a get name method. We created a method within our class or our blueprint for employee that allows us to return the name. Now we could do this a completely different way, actually. Not a completely different way. We could do this in a much more easier way. So you know how it returns a name? Well, you could simply just remove this and then put this actually in there, and then it will print the name for you. So you're probably wondering, like, why, even though we have it just listed like this, oh, not there, let me remove that, listed here, we're like, why isn't it printing anything? Well, the reason why is because we're not telling it to print anything, so we have to actually tell it to print something. So we have a print statement here, and then we print out phoson. Or we can set this into, we can actually push this into a variable, and then that variable can be printed out. I'm going to put back the string for this. Okay, so now what I want you to do is I want you to pause the video and then create the accessor method for the rest of the instance variables that we have here. Alrighty, I hope you managed that. It should be relatively easy. So our next one is a integer and it's an ID. So we want the user to be able to return the ID. We want if the user wants an ID or get the ID from the class or the employee class, then we'll give it to them through the getID method. So we want it to be accessible. So we would say public. And we're returning something. It's going to be an integer. And then we're going to name it getID. Not getOD, getID. Have the parentheses there because every method has its parentheses. So this method does not have any. Most accessor methods are not going to have arguments. Are not going to have arguments because you want to get a value from it. And then we're going to return ID. Let's do it with the wage. With the wage, it's instead not an integer, it's a double. So we're going to be returning a double. And then we're going to have a method name of getWage. So this is the name of our method. Have the parentheses and then have our curly brackets. Then we're going to return the wage to the user. And finally, we're going to have our Boolean whether or not we're active in the company. Public Boolean get active. Get active. And then we're going to have return, what's the name of it? Return active. Now you got to make sure these Now, on the AP exam, when you're going to make accessor or mutator methods, later on, a little bit later in the video, I'm going to explain what mutator methods are. But when you're making these, you don't really have to be like completely calculated when it comes to the spelling. But when you're utilizing an integrated developer environment, or if you're using an IDE here, then you need to have all the spelling correct. And the reason why is because the computer does not know the difference between get active or get whatever this is, right? And that's why you have to make sure that it doesn't get lost when you're trying to access different methods. So we created our accessor methods. This allows us to get our characteristics, allows us to get the instance variables of our employee class. Again, there's no main method because this is simply a blueprint. We have our main method in a sort of demo class, a class that's meant just for the main method and, basic functions. Alrighty, so we want to print out. What do we want to print out? We want to print out the ID. We also want to print out the wage, and then we want to print out active. So we have our ID, and then the name of the method that allows us to get the ID is getID. Employee 2 dot get ID. Hope it's just, yeah, okay, so both of them are capitalized. Parentheses, and then have a close parentheses for the print statement, and then semicolon. We do that for the rest of the instance variables. Wage. Lost my train of thought there. Employee 2 dot get wage. And then finally, active. We access the name through its name, the identifier, and then we access the method of that class, so get active. So before I execute that, let me make sure that everything in this program is correct. So file, save, compile. Alrighty, so everything here is good, or syntactically correct, you could say. Let me compile this. Alrighty, so now just to sum up what we're doing, I want to make sure that we keep going to the the object that we're creating. We're declaring that we want an employee object. We name it. Then we actually create the object with the characteristics of Fozon as its name, 123 as its ID, 30.1 as its wage, and active true as its active Boolean value. And then when we want to access it, we're accessing it through its name, and then we access a method that's within that class. And we're getting that method through here. Let me remove that actually. Good. Alrighty, compile and run. And there you go. It prints out my name, it prints out the ID, it prints out the wage, and it prints out whether or not I'm active within the company, getting all of what the instance variables are here. Let me also try it out without the arguments. So we have a way of actually creating a class without the arguments. So let's see what happens when we print it out. And the name is null, the ID is 0, the wage is 0.0, and the active is false, because that is what the default constructor, this is what you call a default constructor, allows us to do. So the name is null, the ID is 0, wage is 0.0, false, so that whenever we access these values, when we access the name, ID, wage, active, it's going to reflect these values. Whereas these values are subject to interpretation based on the arguments that we use to create the object. Now, we have a way of getting instance variables, but now how do we actually change these instance variables? Well, we have something called Mutator Method. So just like how we utilized Accessor Methods to access it, well, we can have a way of mutating our instance variables through Mutator Methods. Sounds pretty cool. Mutator Methods. I want to go back and put this values over here so that when we test it out, I could show you the actual change of the Mutator Methods. Alrighty. So, unlike Accessor Methods, Mutator Methods most likely will not have a return type because you're mutating a part of the class. You're not accessing anything. You're not expecting something in return. You're changing something that already exists. So you're not really getting anything in return. So the return type in this case would be void. So instead of having, well, we would still have public because we want to access the mutator methods. But in this case, instead of having a Boolean double integer string, we're not going to have a return type. So it's going to be void. And when we have no return type, you do not need a return statement. In fact, do not put a return statement because then the compiler is going to get out of whack because it expects there to be no return value, but you're like, hey, I'm returning something. Why am I doing that? So when we have a void within our method declaration, we shouldn't really have a return statement within the method because then the compiler is going to go out of whack. So when you do have a return type, make sure to have a return statement. And once the return statement happens, once it executes the return statement, it doesn't do anything after that. Whereas if you have a void statement, it's going to go on until it finishes up to the curly braces, but it does not expect a return statement. Make sure not to make that mistake. There's no return statement with a void return type. Alrighty, so now instead of having get active, get name, get ID, or get wage, you're going to have a set name method. Now, unlike the accessor methods, we're actually going to have an argument, and this argument is going to intake or input, get some user input, it gets some input from another class, and it's going to set that as the value of the name, the new value of name. So we can be like, alrighty, we want to get some type of string s from the user. Alright, we're going to get some string s from the user. And whatever string s is from the user, well, that's going to be the new value of name. So the user can access the setName method of the employee class and then change the name of the employee by inputting a certain string within the name, within the setName argument. And when it does that, the argument that they inputted there is now the value of name, so that when we access it later in the program, it is now changed. It's going to reflect that change. So the old value that we utilized in the constructor is no longer exists. It's now changed into the input value of string s. So let's test it out. Let's see what actually happens. So I'm going to have a employee 2 is equal to new employee Fozon 123 30.1 true. Now, just to avoid any hassle or anything like in between, I'm just gonna save this into my clipboard. Alrighty, so now I want to change the value of my name. So let's say they spelled my name wrong. They didn't actually spell my name wrong, but let's say it's not Fozon, it's actually Foz. Then we can access our employee name. Then we access the name. So what's the name of the method? So we can access the name of the method. So our method name is setName. So now we've accessed a method from the employee class. And then what do we want it to change to? Well, we can change it into FAUZ, and then when we do that, it will change the name of the it will then change the name of the initial employee. Alrighty, so then we have system.out.println name plus employee dot get name. Basically the same exact print statement that we had previously, but now there's going to be something changed. And the reason why is because now we've changed the name. We've accessed the name of our employee, or we've accessed the identifier, or where the variable name of our employee, and we're changing the actual name, the name variable of the employee class. So now it's Foz instead of Foz. Fozon, sorry. So let me make sure that the old class is saved. And then let me make sure the class is also compiled correctly. We go back. Let's now compile. And now let's run. And as you can see, the name that we get, the name that we have stored within the value name here is now different. It's now Foz instead of Fozon. I want you to try making mutator methods for the rest of the variables. Sorry, couldn't think of the word. Yeah, variables. For the rest of the variables, I want you to make a mutator method. Alrighty, so I hope you managed that. What you need to do first is you write the method declaration, or the method signature, you could say. So we're like, alrighty, we want to get ID, wage, and whether or not they're active. So public void, because we're not returning anything, set ID. It's going to take an integer I, and then we're going to change ID into I. So whatever the user inputs for the value I, when we're accessing the set ID method, ID will become I. Alrighty, public void set, what's next, wage, and wage is going to be a double, let's put W. Then we set wage is equal to the value of W that the user inputs. And then finally, we're going to have a public void set active, and it's going to be a Boolean value. I'm going to set it to Boolean A. And then Boolean active will be set equal to A. So these are different ways, well, not different ways, these are sort of the same way of making mutator methods, but for different values or different variables of our employee object. So what we're going to first do is we're going to first create the object. Alright, we create the object. Then we're going to print out the object's characteristics. Then what I'm going to do is I'm going to access every object's set mutator method, and then change the values one by one. So instead of Fozon, I'm going to have set name Foz, and then that changes the name of Foz. That changes the name of our employee 2. Employee. Let me make sure it's employee 2. Employee 2. Set name. Sorry, not set name. Our next one is going to be set ID. And our ID is not 1, 2, 3, it's 3, 2, 1. Our wage, we got a promotion, so we're probably going to have a pretty higher wage. Let's put 45.5. And then finally, I'm taking a break. I'm taking a vacation from the company, so I'm no longer active in the company right now. For now, it's going to be false. So we're basically sending arguments into our employee class, and then setting that as the value of our instance variable. So the values that we utilize to create the object, they're going to cease to exist because we're altering the values through our mutator methods. So then let's reprint all the values that we want. So we're going to reprint it and see the change. Again, let me make sure that everything works within our class. Compile, run that. Okay, that's good. Now let's compile this and let's run. And as you can see, I forgot to add a space, so that's on me. But when we create the object and then we access the accessor methods, it returns the instance variables that we use to create the value. So we utilize foson 12330.1 and true to actually create the object, and when we access it through our accessor method, we get those values again. So foson 12330.1 and true. But then we utilize mutator methods, and then we change every single one of the instance variables. So it's no longer fos, it's no longer it's no longer foson, it's no longer 123, it's no longer 30.1, it's no longer true. It's now fos. Our company, our employee ID is 321. We have a wage of 45.5, and we're no longer active in the company. We're taking a vacation. So then when we actually access the methods again, when we utilize the accessor methods to access the instance variables again, well, we see the change reflected. So now it's fos. Our ID is 321. The wage is now increased to 45.5 because that's what we put there. And now our active in the company is false. And that's very powerful. So now we have an employee object. We have an employee working within the company. We have a way of characterizing each and every employee. So we have their name, we have their ID, we have their wage, and we have whether or not they're working in the company. That could be a very powerful tool for business people or people that run companies to keep track of their employees and all that they have. Now, they're not just going to simply have name, ID, wage, or whether or not they're active. They're going to have multiple other things that constitute or characterize the employee within their databases because they're managing all this data. Before I wrap up the video, I'm going to discuss static. Now, as you know, there's actually, let me remove this. You can actually make multiple employee objects. Just like how you can make multiple scanners, you can make multiple employees of the with the same framework. So you're simply just utilizing the framework to make your own object. But like there's not just one employee, there's not that just one student. There's not just one business. We have multiple. So how do we keep track of that? Well, that is where static comes in. So let me create an object first. Employee 3. And this could be just a new employee. And then let's create in like employee 4. And then we're going to set that equal to new employee. And let's have a name. Let's say, I don't know, Mr. Rogers. Have a company ID of 987. Oh yeah, let me remove the quotation marks. Not remove them. Add the end quotation marks. 987. He's making bank, I'm pretty sure. So let's put 100.0, and he no longer works. So we made 3 objects, and we're allowed to do that simply because, well, that's how objects work. We can make multiple objects, but as long as we have different identifiers, different ways of characterizing them, then we have different objects. We have objects that have the same framework at the end of the day. They all have a name, they all have an ID, they all have a wage, they all have some sort of active true or false value. However, these values are different. So we can make multiple things like that. And then when we want to access it, we access it through the get method. So the get and accessor methods. But how do you actually keep track of these values? Like, let's say you have multiple employees. How do you get the value of all the employees? Well, we utilize a static value. So we're going to create a value called private and then we call it static. And the reason why we call it static is because this is the one thing that is shared across all objects. That's going to be shared by all of the employee objects. Let me be more specific. Anytime you create an employee object, it's going to have its own value for name. It's going to have its own value for ID. It's going to have its own value for wage. And it's going to have its own value for active. However, if you have a static variable, it's shared with all of the classes. It is shared with all the classes, meaning that the value of, let me put employee count, and let me set that equal to 0. If I access employee count from the employee count from employee 2, it's going to be the same as if I access it from employee 3 or employee 4, because this is a variable that they all share, because I emphasize that this is static. So it's going to have one place where the memory is allocated, and that memory is shared across all every time we create the method, every time we create the object. So this is something that's shared across all of them. Whereas if we have a name, we have an ID, we have a wage, and we have an active Boolean expression, that is not shared across all the objects. Each object actually has its own name. So this object has the name Fozon. This object has the name Mr. Rogers. This object has the name 123. This object has an ID of 0. This one has an ID of 987. These are different values, but they're all going to have the same employee count because they're all part of the same company. So if they're all part of the same company, we need that value to be shared, employee count. We want that employee count to be all shared. So how do we make sure that these employee counts are actually kept track of? So whenever we create the object, what I want to do is I want to increase the value of employee count by 1. So we can do that two ways, actually. We can do that through the increment operator, or we could do employee count is equal to employee count plus 1. But I'm going to just do the increment operator because it's so much more simpler. And we do that in both constructors because, well, there's different ways to make employees. Alrighty. So whenever someone creates an employee, what happens is that the employee count actually increases by 1. So if I make 3 objects, what's going to happen? Well, this object is going to make employee count equal 1 because it increments it to 1. Employee 3 is going to increase the value of employee count by 1 again, so it's going to make it 2. Employee 4 is going to make it, I know the numbers are throwing me off because it says 2, 3, 4, even though this is the first one, this is the second one, this is the third one, but this is going to actually increase the value to 3. Again, right, this is shared by all instantiations of the class. This is how you instantiate the class. All right, let me emphasize that. That's how you instantiate a class. So when I mention instantiation, this is shared by every single one of them. Whereas these values, these are not shared. They have each of them have a name, ID, wage, or Boolean value for active, but they're all different values. It's unique to the class. Whereas this employee count, they're all the same for all the classes because I'm increasing it whenever I create the object. So you can see the change. Oh yeah, so to access employee count, what we do is we create a static method. It's basically an accessor method, but instead of having just a return type, just an identifier, and just public, we have to include static because, well, static emphasizes that every class shares it. So public static integer, did I mention that it's an integer? That was a close one. Private static integer employee count, good. Alrighty, public static integer get employee count, and since the accessor method we don't need any arguments, so when we put the arguments there, then we can return, once we put the curly brackets there, we can return employee count, and boom, we got that. And let's compile to make sure everything works. Let me save it, and then once we save it, we can now access it. So this is sort of a weird way of accessing it it's sort of a weird way to actually access the employee count. So instead of calling it by employee 2, we actually call it by the class name. Since it's shared by all the classes, since all the classes have a shared variable, then we simply call it by the class name. So if we want to print out system.out.println employee dot get, let me make sure that I spelled the get employee count correct. You know, just better yet, I'm just gonna save that to my clipboard. Alrighty. So now we're gonna see the value change, the employee count value change every single time we create an object. And then we run it. And as you can see, employee count goes from 1 to 2 to 3. And the reason why is because when we create the object, what it's doing is that it increases the value of employee count every single time it's created. So when it gets created, even if we have no arguments, we still have it within our default constructor. So it increases the value of employee count whenever we access this constructor. When we're accessing this constructor, we're accessing the constructor from here. So when we're accessing it, we're also inherently increasing the value of employee count by 1 to say, hey, when we create an employee, we also want to add another person to the employee count. And that changes every single time an employee is made, because the value keeps increasing every single time we create an employee object. And that should be your introduction to methods, classes, and objects. It's a pretty big video, and the reason why I have this video so that you can take time to pause it, take time to emphasize or relearn some of the concepts, and in some shape or form, once you're done reviewing the videos that I have later on, you can come back to this video as a review video to combine all the concepts together, because a big portion of not only the AP exam, but in future computer science classes in general, and a very powerful tool in the professional world, is object-oriented programming, or your ability to look at an object in real life and then make the object within the programming language, within Java, for instance, in this case. It could be in a different programming language, but we're doing Java right now to show you object-oriented programming. And as you can see, we pretty much made an employee, or a digital representation of an employee, with our Java programming language. We made basically a framework for an employee. We gave it a name, we gave it an ID, we gave it a wage, we gave it whether or not it was active in the company. Ooh, that's pretty cool. And it has these unique characteristics that make it an employee. And then we also have a shared value between all these objects, and that is how many there are. So like in a business, how many people are in this how many employees do you have? Well, we need to keep track. So whenever you add an employee, then you want to increase the employee count. And that is irrespective of if it's an employee 1 or employee 2. You're still part of the same company that has this many employees, and that's why it's shared. So again, there are multiple concepts. Pause the video if you feel like you need to review some of them, and try doing this with a bunch of other objects, such as students. That's a pretty easy one. It replicates pretty much the employee one, but with like different characteristics. So instead of having like a wage, you're gonna probably have maybe a GPA and stuff like that. So that wraps up my video on methods, classes, and objects. I hope you had fun with it.